factors and monomials. So first off, before we start, what is a monomial again?
Like a term?
A term. And so what's a term?
A number, a variable, or a number.
Perfect. A number, a variable, or a product of the two, right? And when we talk about variables, they could have exponents or they didn't have to have exponents. That's okay. All right, so in the first section, we talked about divisibility rules. What numbers did we have for divisibility rules? 2, right? What was our rule for 2?
Even.
It has to be an even number, okay? 3,
If you can add them up.
if you can add them up and divide by 3, then it's divisible by 3. There wasn't one for 4, right? 5,
If the number's
ends in a 0 or 5. 6,
If 2 and 3 work.
2 and 3. That's the important part, the and in there. 7 dent, 8 dent, 9 dent, 10. If it ends in 0, right? So you could use those rules to find the factors of any single number, or what did I have to do if I wanted the factors of a number? I could do what?
Prime factorization.
I could do the prime factorization. Or I could just list them all out, right? How do I know when I'm done with all of the factors of a number? When they get really close together, or are the same number, or they go past each other, right? Then I know. So again, if they ask me to list all of the factors, I gotta even list, what did we forget? 1 and that number, right? So don't forget about 1. Okay? So, in 9 through 16, would you want to do any one of those? Again, make sure you read the directions. This one just says by the divisibility rules. So, are we okay with that? What are we looking for, though? If they're the factors of that number, factors mean what?
You can like divide the number by that.
Okay, so 2 numbers that multiply together, or you can divide by that number. Exactly right. We're okay with that section? All right, turn page. So then we went to powers and exponents. Some of the things that we talked about with exponents was that, what does it really mean for an exponent?
You're taking the number that is like the base of the exponent times itself to the number exponent times it.
Exactly right. The number that I would multiply the base times itself. So what's important? It's important if my base is a negative number, that I put parentheses around that negative number, especially if I'm going to put it into my calculator, because the calculator is not as smart as us and they would do it different, especially if it's an even exponent. What else? Make sure that if it's a number that you calculated out, okay? Anything, meaning a number or a variable raised to the 0 power, ends up being what? Anything raised to the 0 power. 1. My answer is 1. Okay? So, in this section, 4-2, we're basically putting in and substituting what they tell us. So, something like number 22. What is being raised to the 3rd power? Just the y, right? So, what does it mean when they say x, y cubed, though? What's happening between x and y cubed? Their multiplication. So, if I'm going to do this problem, what do I have to do first? I got to do my exponent first. So, I have to take y cubed and then multiply that answer times my x. Everybody agree with that? Okay, so look through 17 through 24. Any of those you would like to see? Yes, ma'am. 24. Awesome. So in 24, they tell me that I have a number outside parentheses. 2 parentheses 3z plus 4 raised to the 5th power. So this is a good one. So then z, they tell us, is -2. That's the only thing we need to know. So again, now we're going to go back to the order of operations, or PEMDAS, right? That's really important that we remember this now. So in PEMDAS, it says that we always have to start inside parentheses. So we're going to go inside and try to simplify. Can I take 3z plus 4? Not really, right? So I'm going to simplify by doing, what does 3z mean? It means that I'm going to multiply whatever 3 times z is. So what's 3 times -2? -6. So we keep writing things down. Now, where do we go?
-6.
We're still going inside parentheses, right? So -6 plus 4 is? -2. Now, we have multiplication and we have an exponent. So what do we got to do first?
Exponent.
So what's -2 to the 5th power? -2 times 2.
4.
Times -2. Times -2. Positive 16 times -2. So -32 times 2. Positive, or sorry, -64. Everybody agree?
Why would it be negative?
Because I have 5 negatives. Negative times negative is positive, negative, positive,
Well, why
negative.
would your answer be negative?
Because a negative times a positive is always negative. Right? A negative times a positive?
Or you?
I thought there was an exponent there, but.
Go back to the sky. All right, any more on that one? That section. Yes, sir.
23.
23. Perfect. So, 23. We're still using our z again, but we had 7y to the 0, I think, z to the 4th. Is that what it was? So, anytime that I see 0 as my exponent, I'm basically going to cross that out because it's just 1. So I'm just throwing it out of the problem. Okay? So my z again is -2 to the 4th times 7. So again, what's -2 to the 4th?
16.
Positive 16, right? And then I would take 16 times 7. So what do we get?
112.
7 times 6 is 2, carry the 4. 112 sounds good to me, buddy. Everybody agree? Okay. Any more in that section? So again, the most important thing is going back and doing PEMDAS, our order of operations. But again, like I said, with this one right here, anytime that I have 0, I'm always looking for zeros. Zeros are awesome. Whether I'm adding or multiplying or exponents. Okay? Good to go? Next section was about prime factorization. So now I'm trying to list all of my factors, but each of my factors has to be a what? A prime number, right? What's a prime number?
One factor.
The only factors are 1 and itself, okay? The other thing that you got to remember when you're doing your prime factorization, I'm going to make my tree, and I'm going to keep breaking it down. So the first thing that I have to find are 2 factors of some number, right? I don't care what the numbers are. It can be any sets of factors, and some numbers have a lot of them. So you just have to have 1 set of factors. But if the original problem, which is a monomial, is negative, don't forget to list what? -1. Has to be a part of your answer. Okay, so 25 through 32. Also, sorry, when you're doing your variables, make sure you have to list each individual variable. So like in 31, you should have 3 p's in your answer, right? P times P times P. You have to list them all out. So any of those numbers you want to look at? 25 through 32? Yes, sir.
I don't want to look at one, but wouldn't every number be composite? Could you take a decimal number?
No.
Times,
It's always got to be a whole number factor. Good question, though. So yeah, there could be a bunch of them if you included decimals, but we don't do Good question. Okay there? All right. 4 was greatest common factor. So this meant what? What's an easier way of saying the greatest common factor? The biggest number that I can divide both numbers by. Okay? So what were my options to finding this greatest common factor? What? List all of them, right? That one kind of stunk because some of them would be ginormous. But we can always do that. What else? The prime factorization, right? We did the prime factorization for both numbers, and then we would go through and pick out what was in common in both, and then multiply those numbers at the end together. Don't multiply them across, just in one or the other. Okay, so in this one, again, some of these are hopefully getting a lot easier for you. So if we looked at 33, what's the biggest number that I can take out of both of those? 6, right? So again, when you start doing this, always look at one of the numbers as being a factor. Is one of the numbers a factor of the other number? That's what you have to ask yourself. And if it is, that might be your biggest one, especially when 6 is kind of a smaller number. When you're looking at like 35 and 36, remember when we're talking about the variables, we're just saying the same thing. I always want to take as many variables that I can from both numbers, but sometimes they might not even include that in the answer. It's got to be in both of them to be included in the answer. So, anything from 33 through 36? Sometimes these aren't as hard as the ones that I give you. So, 37 through 39, what are we doing in 37 through 39? If I'm taking out that common factor, what did I call this? We're going to undistribute it or factor it, right? So when we undistribute, we're taking something out of both of those terms, and this is where you got to end up having parentheses in your answer, right? So 37 through 39, do you need an example of one of those? See one of those? 37. 2t plus 20. So again, I'm looking at those two terms and I'm asking yourself, what's the biggest number that I can take out of both individual terms?
2.
Just 2, right? So that number is going to go outside my parentheses. And then basically I take that common term and I divide each of my terms by that thing that I took out of there. So what's 2t divided by 2?
T.
Just t. What's 20 divided by 2?
10.
Plus 10. So along all of this, make sure that you include all of your multiplication and division rules too, right? If there's the signs are the same, my answer is always positive. If the signs are different, my answer is always negative. Okay? But this is essentially my answer. Again, anytime that it says to factor something, you should always have a multiplication problem at the end. Okay with that? Again, you might have to do this multiple times if that number that you took out the first time wasn't the biggest number that you want. You always need to make sure that you get the biggest. So after you do this one time, take 2 seconds to look at your terms and make sure that they're still in simplest form. Because if they're not, then you got to do it again and take that out there, and then you would multiply those numbers. So that's where it's beneficial in those problems to find the greatest common factor. But you can just do it as many times as you want too. But some of you don't like to do the problem one time, let alone 3 or 4 times. You won't name any names or anything. What are you talking about? We're in the same boat.
You know what it is. I wonder who it is. Everything I can. Yeah.
All right, 4 or 5. It says simplify algebraic expressions. What's simplify mean?
Make it into the simplest form.
Simplest form, right? So we are trying to find something to divide both the top and the bottom by. And we have to take as much as we possibly can. So again, these are problems where if they're really big numbers or terms, you might have to do this more than once if you don't take the time to find the greatest common factor. So if it's an even number, I can always just start out by doing 2, but I might have to do 2, 4, or 5 times. Okay? So 40 through 47, any of those you want to look at? 47. Perfect. So we're looking at common pieces. What's the biggest number I can divide 15 and 24 by? 3, right? So I'm going to come and I'm going to do that. And again, if you have to show yourself that. Divide by 3, divide by 3. Or I'm going to come through, because I've done it so many times, I'm just going to start crossing them off because I know I'm going to. What's 15 divided by 3?
5.
Because it's on the top, it's got to stay on the top. What's 24 divided by 3? 8.
What did he say? Did he say 20?
I think so. Now I go through my variables, right? There's an A on the top and the bottom, so we cross those out. But remember, we're dividing, so it's not 0, it's 1, right? There's really a 1 there, but we don't have to ever show 1s. And then there's only one group of C's, so they stay on the top. And there's only a group of B's, but they got to stay at the bottom. So you can't just put them wherever you want either. You got to keep them where they are. Okay? Questions there? Turn the page. Now we're thinking about multiplying and dividing monomials. Again, this isn't a really good problem. These aren't really good problems because they don't give you much. Let's jump over to number 18. This is a good one. Number 18 on the next page, 195, shows a little better. But when I'm multiplying exponents, what do I really do to them? I really add the exponents. So I still multiply the coefficients, which are the big numbers in front of the variables, but I add the exponents. Okay? Again, if I can punch it into my calculator, I'm going to punch it into my calculator. If I go back to number 48 on the page that we're looking at, I want to make sure that I punch 8 to the 9th into my calculator. Don't just leave it as 8 to the 9th. If you forget a calculator, then you got to start doing math, and it's going to take you a long time. Okay? Maybe we'll try that at the end without a calculator. So, what do we get? Let's go back to 18 on page 195. What do I get on number 18?
Negative 4x to the 11.
Next to the what? 10. 7 plus 3 is
I
still
thought
10.
that was a 4.
Okay? So, what do I do with division problems?
You subtract the variable.
I can subtract them, or I just think about what? Or I just think about simplifying, right? So there's two different ways. Because now that we understand that we can subtract the top minus the bottom, we would get 11 over 2 here. But we can just cross them out. I'm taking 7 away from here, so I get 11 squared either way. Now, when we introduced the subtraction part, we always wanted to do the top minus the bottom because we didn't know this next section. And the next section was about negative exponents. And what was true about negative exponents? We never wanted them where? In our answer. So how did we get rid of something that had a negative exponent? We moved it across, right? So if we just did this problem right here, but flipped the numbers around, the exponents, we would have had 11 to the 7th or 11 to the 9th. So you could have done this 2 different ways again. I could go back to the rule and say, I'm going to do 11 to the 7 minus 9, which is 11 to the negative 2. But we just got done saying that we can't have this. And remember, every single number is always a fraction over 1. So when I move it across that fraction bar, it makes my exponent turn into a positive. And then I have to have that 1 on top. Over here, we could have also just thought about simplifying it by crossing out the same number, right? I'm going to take all 7 of those. I'm going to take 7 of these, and there's 2. But I have to, in this instance, make sure that I leave my 11 squared on the bottom. Okay, so it's the same way of doing the problem, it's just two different versions of it. All right. So what's 11 squared?
132. 20. Wait.
Is it 121?
Oh.
You're way off today.
I was off by 100.
Well, you had 20 for the last one, and it was like 2 or something.
8.
There was 8, you said 20.
Alright,
Sorry,
so,
said 60.
something like number 57. Everybody look at 57 real quick. When we move this to the bottom, does the negative in front of the 4 change?
No.
No. So remember, this one would have been this. What was the next one?
3.
So it would have been, ended up being this right here. But I have to include this negative inside my parentheses. So when the number part moves down, that negative stays with us. But when the exponent moves down, it gets turned to a positive. It's a big deal. And then we have to simplify, right? So negative 4 times negative 4. Still 16. 16 times negative 4. Holy cow. 2 days away from math and you guys can't do anything. 20, 16, 4, 8.
No, it is.
Alright, makes sense though what I'm saying there? Okay? And then the last section was about our scientific notation. So do we need to see any of those? Do we remember what was the number after trillions?
Quantum. Right?
What?
It was quadrillions, wasn't it? Okay. So, we got 5 minutes. This is what I want you to do. Here we go. Everybody get a little piece of paper out. I don't care, scratch piece of paper. It doesn't have to be anything special. Put your calculators away. No calculators. We're figuring it out 8 to the 9th. Go.